Hey everyone, today we're gonna start a new lecture on exercise number 4.2. So we're gonna talk about the four identities first. The first identity is a cube plus b cube. It is equal to a plus b, a square plus b square minus ab. Then the second identity is a cube minus b cube. It is equal to a minus b, a square plus b square plus ab. Then we have two more identities that we need to discuss, that is a plus b whole cube. It is equal to a cube plus b cube plus 3a square b and plus 3ab square. Then the last identity that we're going to use in this exercise is a minus b whole cube. It is equal to a cube minus b cube minus 3a square b, but it is added with 3ab square. So we're going to use these identities throughout the chapter of factorization and algebraic manipulation. So let's say this is the first formula, this is the second formula, this is the third, and this is the fourth. States that we need to factorize the following expressions completely. The expression that we're given is x power 3 minus 125. X power 3 minus 125. So first we need to simplify this. 125, what is the cube of 125? That is 5 power 3. So we will write x power 3 as it is, while we'll write 5 power 3. So 5 power 3 is equal to 125. Then as you can see, we have put this into x power 3 minus 5 power 3. So we're going to use the second formula, which was a cube minus b cube. It is equal to a minus b, a square plus b square plus ab. So firstly I will write is equal to, then I'll write a subtracted from b. Suppose x is a and let's suppose b is 5. So I'll write x minus 5. Then I'll write a square. Now what is a square? We'll take x and we'll take its square. Then we have b square, so the square of 5 will be 25. And then we will write ab. So ab will be 5x, since x and 5 combined together is 5x. So I'll write it here. So this is your answer for the first question. Now let's move on to the second question. In the second question, the expression is 8x cube plus 1. So how are we going to simplify this expression? Let's see what is the cube of 8, that is 2. So I can write 2x whole cube plus the cube of 1. So now I have arranged this expression into the a cube plus b cube formula. Let me remind you, it is equal to a plus b, a square plus b square minus ab. So I'm gonna put this expression into this form. So it is equal to a plus b. What is a in this case? It is 2x. So I'll write 2x plus 1. After writing 2x plus 1, then I'll write a square plus b square subtracted from ab. So a square is 2x 4x whole square. So I'll write 4x whole square. Then it will be added with 1. Why? Because the square of 1 is always 1. And then subtracted from ab, which is 2x. So this is your final answer of the question 2. Now let's move on to question number 3. Question number 3 states that we have an expression which is 3p cube q cube and it is subtracted from 81 x cube. Now first we need to see what is the common element between these two terms. So we can see that 381 can be divided with 3. So we'll just take 3 as a common value. So we'll use the parenthesis and write inside here p power cube q power 3. Then 81x cube, it will be simplified to 27x cube. Why? Because 81 divided by 3 is 27. Now I have this in the form of a minus b, a cube minus b whole cube. So just I need to arrange it. So let's assume p cube q cube can be written as pq whole cube, and 27x cube can be written as 3x whole cube. I'll put this 3 behind these two, but for now I won't because we don't have that much space. So pq cube is subtracted from 3x whole cube. It will be equal to the second identity, which was a cube minus b cube. So first we will write a minus b. So a in this case is pq subtracted from b, which is 3x. Then I'll write a square plus b square minus ab. So a square in this case is p square q square. Then we have plus b square, so I'll write plus, and b is 3x, so it will be 9x. Then I'll write subtracted from ab. Sorry, I'll write added with ab because this is the second identity, and then I'll write 3xpq. So this is our final answer. And we'll add 3 here with the brackets, and then we'll add 3 here too. So this is our final answer for question number 3. Now let's move on to question number 4. In question number 4, we have the expression of 27 added with 512x cube. Now let's assume that the cube of 27 is 3 cube, and then the cube of 512 is 8x whole cube. Now we have this expression in the form of a cube plus b cube. We can easily use this in the formula. So 3 cube plus 8x whole cube will be equal to a plus b. So I'll write 3 plus 8x because 3 is a and 8x is b without the cubes. Then I'll write a square plus b square minus ab. So a square in this case is 3, so that will be 9. Then b square is 64x square. Then I'll subtract it from ab, 24x. So this is our final answer of question number 4. Now let's move on to question number 5. In question number 5, the expression t power 6 minus 64 is written. Now we can write t power 6 as t power 3 whole power 2, and then we can write 64 as 8 power 2. Why? Because there is square, whole square on t, and there is square on 8. So now we're gonna use the formula of a square minus b square first. Then after simplifying it, we're gonna put this into the a cube minus b cube form. So I'll show you how you can do that. So firstly, what I will write is that I'll write t cube plus 8. Then I'll write t cube minus 8. Now after writing this, we will simplify this much further. You can see that the cube of 8 is 2 cube. So I'll write t cube plus, we will write 2 cube. Then I will write t cube here subtracted from 2 cube. So now we have these two terms, these two pairs of terms which are in the format of a cube plus b cube and a cube minus b cube respectively. So we'll apply the first formula on the first term and the second formula on the second term. So let's apply a cube plus b cube on the first term. So I'll write t plus 2. I'll write t plus 2. Then I'll write t square plus the square of 2, which is 4, subtracted from ab, which is 2t. So I wrote a cube plus b cube for the first term. Now I'll write a cube minus b cube for the second. So that will be t minus 2. Then we'll also have t square. So I'll just write t square here. That will be added with 4 and added with 2t. So this will be our final answer for the expression question number 5. Now let's move on to question number 6. In question number 6, we have the expression of x power 6 being added with y power 6. Now we need to simplify this. This is basically as the same as the previous expression. We're gonna write x power 3 whole power 2 because we're simplifying it. So 3 2s are 6. So this is basically equal to x power 6 just in its simplified form. Then I'll write y power 3 whole power 2 for the second term. So now, okay, so we have a problem here, as we know that a square subtracted from b square is equal to a plus b and a minus b. But there isn't any formula for a square plus b square. So what are we going to do? We are basically going to swap the terms. Swap the exponents, not the terms. We are going to swap the exponents and we will write then x power 2 whole power 3 and then we'll write y power 2 whole power 3. So in this case now we can use the formula of a cube plus b cube. Now the first term is x square, we'll call this a, and then y square we'll call this b. Now let's apply this to the formula. So it will be x square plus y square. Why? Because this is a and that is b. Then we'll have a square. So a is x square. The square of x square will be x power 4. Then b square will be y power 4 subtracted from x square y square. So this is our final answer of expression question number 6. Now let's move on to the question number 7. The expression states that 2 minus x whole cube is added with y minus 2 whole cube. So what will we do in this expression? We just need to convert this into the a cube plus b cube form. So let's suppose let 2 minus x is equal to a and let y minus 2 is equal to b. Now we'll just put it into the a cube plus b cube form, which will be equal to a plus b, a square plus b square minus ab. So now we need to place the values. So the value of a was 2 minus x. So I'll just write 2 minus x, which is a, being added with b, which is y minus 2. So this is b. Now I'll write a square. So what is a square? That is 2 minus x whole square. It will be added with b square. Now what is b? b is y minus 2. So I'll just write here y minus 2 whole square. Then we have ab. This means that 2 minus x and y minus 2 will be multiplied with each other. So I'll just write 2 minus x as it is, and then I'll write y minus 2 as it is right here. Okay, so after writing this expression here, okay, I think we missed a bracket. Let's put it here. Now what do we need to do to simplify this equation much further? This will stay as it is. So 2 minus x being added with y minus 2 will just remain the same, but 2 minus x whole square, so the square will be applied to 2, which will result in 4, then minus x whole square, then we have plus, this will be y square minus 4. Then what will happen is that we will add, now these two terms will be multiplied with each other. So how can we do that? First we'll write y. So I'll write y bracket 2 minus x and then subtract it from 2, and then I'll write 2 minus x. Now we need to simplify this much further now. So the rest of the content will remain the same. So 2 minus x plus y minus 2, 4 minus x square plus y square minus 4, it will remain the same, but plus, so we need to simplify this. So y multiplied 2 is 2y minus xy minus 4 plus 2x. So this is the simplified equation expression, but there is still some work left to do. So this is positive 4, this is negative 4, they will cancel each other out. Then we have negative x square, and we don't have anywhere x square, so this will remain the same. Then we have positive y square, it will also remain the same. Then we have 2y, so 2y will also remain the same. So this will be our answer. So I'll just write 2 minus x plus y minus 2. Then I'll write negative x square plus y square added with 2y subtracted from xy, and I'll write negative 4 plus 2x here. So this is our final answer for expression number 7. Question number 8. The expression states that 64 bracket x plus y bracket close whole cube is subtracted from z cube. So in order to simplify this expression, we can write 4x plus y whole cube. It is the same as 64 bracket x plus y cube, and then we will write z cube as it is. After doing this, we can use the formula of a cube plus b cube. A cube minus b cube is equal to a minus b, a square plus b square added with ab. So if we place the value of a here, a is 4 bracket x plus y, and b is z. So to write a minus z, I just write 4 bracket x plus y minus z. Then for a square, I will write 4 bracket x plus y whole square. It will be added with z square, and then we need to multiply a and b. So that will be 4 bracket x plus y with z. Now we need to simplify this expression. So 4 bracket x plus y minus z will remain just the same, but now this will be 16 x square plus y square added with z square, and then 4x plus yz. So this is our answer for question number 8. Now question number 9 states that we have an expression which is 27p cube being added with 144 p q square subtracted from 108 p square q, and it's again being subtracted from 64 q cube. Now how will we solve this expression? Firstly, we will write 27p cube with 64q cube and 144p square with 108p square cube. So we'll write 27p cube subtracted from 64q cube added with 144p square, then subtracted from 108p square q. After writing this, then what we will do is simplify the term 27p cube, so we can write it as 3p whole cube, and then 64q cube can be simplified as 4q whole cube. Then we will add this, so we have 144 and 108. If we take the LCM of 144 and 108, the resultant will be 36. So 36pq is common between these two terms, and then when 144 is divided by 36, it will be 4. P and p will be cancelled. Q square divided by q is q, subtracted from, now we will divide 108 by 36, so we will get the answer of 3. P square divided by p is p. Now what will we do? We have 3p square minus 4q cube. So we need to simplify this terms into the formula of a cube minus b cube, which is equal to a minus b, and then a square plus b square plus ab. So let's write this term. Let's consider a as 3p and b as 4q. So I'll write 3p minus 4q, then I'll take the square of a, which is 9p square, along with the square of b, which is 16q square. After that, I'll just take both of their multiplication, which is 12pq. Now what do we have next then? Plus 36pq with 4q minus 3p will just remain as the same. Now this is 3p minus 4q and this is 4q minus 3p, so they are entirely different. We need to make them the same. So in order to make them the same, this positive will be changed into the negative sign, and then after it's being changed to the negative sign, instead of 4q minus 3p, we will erase this and we will write 3p minus 4q. So the signs are now changed. So you now can see that 3p minus 4q and here 3p minus 4q are the same. So we can take that as a common element. So I'll just write 3p minus 4q. After taking it as a common element, I'll write 9p square added with 16q square added with 12pq subtracted from 36pq. Now here we have 12pq and negative 36pq, so both of these will be subtracted with each other. So when they are subtracted with each other, we will get the resultant of negative 24pq. So I'll just write 3p minus 4q, and then I'll write 9p square being added with 16q square, and then I'll write negative 24pq. After simplifying this expression, now you can see that we have a quadratic expression right here where the coefficient of p square is 9 and the coefficient of pq is 24. But if you look here, this is 9p square, so we can simplify this much further, and 16q square, so we will simplify the expression more. So we will write 3p minus 4q, it will remain the same, but instead of 9p square we will write 3p whole square as it is the same, and then we'll expand 16q square to 4p whole square. After doing that, we will then subtract it from 2ab. Why? Because this applies to the formula of a minus b whole square. So I'll just write 2 bracket 3p, and then another bracket I'll just write the value of b. So I wrote these values. Now I can write 3p minus 4q, and instead of this whole expression I can just simply write 3p minus 4p whole square, because this expression is equal to that. So now we have 3p minus 4p whole cube. That will be our answer. Now let's move on to question number 10. So I'll write question number 10 right here. So question number 10 states that we have 8p cube being added with q cube, and it's added with 12p square q, and added again with 6pq square. So first we need to check. So this is cube with cube, this is square with square, so we will not change the order of these terms. So here we have 8p cube, we can simplify this to 2p whole cube. So this is exactly as the same as 8p whole cube, but we have expanded it, and then q cube will just remain the same. Now look at this two terms, they fit right perfectly into the formula of a cube plus b cube. And then here we have 12p square q and 6pq square, so I'll just take the common value between them, which is 6, because 12 can be divisible by 6. So I'll take 6pq as a common element, and then I'll have 2p plus q. Now what will I do next? I'll pick the values of a and I pick the value of b and place it into the formula of a cube plus b cube. So firstly we will write 2p plus q, then we will write 2p whole square, we will add it with q square, and then subtract it from 2pq, and then the remaining 6pq bracket 2p plus q will remain just the same. Now let's solve this much further. So we have 2p plus q here and 2p plus q here, so we'll just grab the common value between them, which is 2p plus q. It will remain as the same, but then we will simplify this expression. And we will have 2p plus q whole square. Why? Because this was a square, this was b square, and this was 2ab. So if we fit this into the formula, it becomes 2p plus q whole square. And I think I made a mistake here. Positive value will come, not negative sign. So now we have 2p plus q and 2p plus q whole square. So both of these will combine to produce 2p plus q whole cube. So this is the answer for expression number 10. Now let's move on to expression number 11. Expression number 11 states that we have 125x cube subtracted from b cube, then again subtracted from 75x square y, and being added with 15xy square. So as you can see, this is the cube with the cube, this is the square value with the squared value, so we do not need to change the order of these elements. Now what will I do next? I'll basically simplify and expand this term, which is 125x cube. It can be written as 5x whole cube. It is just the same as 125x cube. Then y cube being simplified will just be y cube. Then we'll subtract. As you can see, we have 75x square y and 15xy square. So the common value between them is 15. Why? Because if we divide 75 with 15, the resultant will be 5. So let's type 15xy here. And then what will be the common value? We will write 5x minus y, because minus and plus is always minus. So now we have 5x whole cube minus y cube. These two terms can fit into the formula of a cube minus b cube. So what will we do next? We will write here 5x minus y and then 25x square, and we will write y square because we are simplifying it into the a cube minus b cube form. And then I'll write plus 5xy. Now the second part, which was negative 15xy, bracket 5x negative y will just remain as the same. Now what will I do next? I'll just write here 5x minus y. I took it as a common value. And then I'll write 25x square being added with y square. After that, I'll add 5xy and subtract it with negative 15xy and close the parenthesis. Now 5xy subtracted from 15xy will produce negative 10xy, and then we have y square being added with 25x square. We'll close the parenthesis here and we'll write 5x minus y as it is. Now here, what will we do next? As you can see, this is 25x square, so we will simplify it first. So first let me write 5x minus y. It will remain the same, but 25x square can also be written as 5x whole square. Then we can write y square as y whole square. Then negative 10xy, we can expand it. So in the form of 2ab, it will be 2 bracket 5x, and here we will have y. So after writing that, we can conclude that this whole expression is equal to a minus b whole square. So we need to convert this into the a minus b whole square form. So let's suppose the value of a is 5x and b is y. So we will write 5x minus y whole square. So first let's write 5x minus y here, and then I will write 5x minus y whole square. Now both of these terms will combine to produce 5x minus y whole cube. So this is our answer for question number 11. Now let's move on to question number 12. Here in question number 12, it is stated that p cube is being subtracted from p cube is being subtracted from 9p square q added with 27pq square and then subtracted from 27q cube again. Now let's first look at the form. So this is cube with a square, that is incorrect, and then we have a square with a cube. So what do we need to do? We need to place this cube with this cube and then this square with the square. So I will write here p cube minus 27q cube subtracted from 9p square q plus 27 pq square. So after writing this expression, now the form is correct, cube with cube and square with square. So I need to simplify them now. So p cube can also be written as p whole cube, and 27q cube can be written as 3q whole cube. After that, we will subtract the value. Now look here, 9p square q and 27pq square. what is the common value between them? So the common value between them is 9pq. So I'll choose 9pq. After choosing 9pq, we will write p minus 3q. Why did we write p minus 3q? Because we divided these with this. Okay, so let's go below. Now we have p cube minus 3q whole cube. We will write this in the a cube minus b cube form and then further simplify it to see what the answer is. So I'll write p minus 3q, then I'll write p square plus, I'll write 9q square then, so I'll just write 9q square. After that I'll write it's being added with 3pq. So this is the completed form of a cube minus b cube. Now what do I need to do next? Yeah, I'll just write this part which was 9pq, this above part, this. So I'll just write 9pq bracket p minus 3q as the same. Now look here, we have p minus 3q and here we also have p minus 3q. So we'll take it as a common value. So I'll just write p minus 3q as the same only one time, and then I'll write p square plus 9q square added with 3pq, and now inside of this parenthesis we're gonna have negative 9pq and then the parenthesis will close. So now we have 3pq being subtracted from 9pq. The answer will be 6pq, negative 6pq, and then we'll write p minus 3q. After that we will write p square plus 9q square, and it is being subtracted from negative 6pq. So I'll close the parenthesis now. Now what do I need to do next? I need to simplify this expression. So obviously we know that we are going to convert it into a minus b whole square form, but before that we need to simplify it. So let's write p minus 3q. It will remain the same, no changes to that, but p square will be written as p whole square added with, instead of 9q square we're gonna write 3q whole square, and then this is 2ab, so we need to expand it to, so we'll write 2, then we have a as p and b as 3q, so we expanded it. Now we can easily convert this to a minus b whole square form. So p minus 3q, and then I'll write p minus 3q whole square. Now both of these terms will combine to produce p minus 3q whole cube. So this is the answer for question number 12. Now we will move on to question number 13. So I'll write question number 13 here. Now we have a different type of expression. It is type 2 expression. So I'll just write here 2x square minus 3x plus 6. This is our first quadratic expression, and then we have 2x square being subtracted from 3x and subtracted from 55 at the end. Now how can we solve these types of expression? So firstly, look here, we have 2x square minus 3x, and then we have 2x square minus 3x here too. So this is the common value, right? So let's just consider it as x. We will write let 2x square minus 3x be equal to a. Let's consider it as a. Now we can easily write a plus 6 instead of this whole value, and I'll write a here again because we replace this value, and now it's being subtracted from 55. Now what is the next step? So a will be multiplied with a here, and a will also be multiplied with 6. So we will have a square plus 6a minus 55. So what is this? This is a quadratic expression and we need to find the factors. So look at the coefficient of a square, it is 1, and here the numeral value is negative 55. So let's suppose 1 multiply negative 55 is negative 55. So we need to find the value of negative 55 such that when we add them up or subtract them, the resultant will be positive 6. So the factors for negative 55 are 11 and negative 5. So if you multiply these values, you will get negative 55. And if you subtract them, you will get the value of positive 6. So we're going to use these two factors for this quadratic equation. So I'll just erase the work that I did here just to give you an idea of how it worked. So I'll write a square, and instead of 6a, I'll write the factors that I just found, which were positive 11a and negative 5a. After that, I'll write negative 55 as it is. So look, we expanded this expression from 3 terms to 4 terms now. So we'll take both of these terms and make pairs between them. So what is the common between these two terms? It is a bracket a plus 11, and then I'll take the common value between these two. It will be negative 5, and then I'll have a minus plus is positive 11. So the first factor will be a plus 11 and the second factor will be a minus 5. Now I found these two factors, but the expression isn't just complete quite yet, so I need to place back the value of a. So the value of a, what was the value of a? It was 2x square minus 3x plus 11. Now we need to place this value in a plus 11 and as well as a minus 5. So let's do it for a plus 11 first. So I'll place it here. So that will be 2x square minus 3x plus 11. So this will be our value. And then I'll go for part B. It is a minus 5. So I'll place the value of a here. So a is 2x square minus 3x. Now it will be subtracted from 5. And I made a mistake right here. The value of a was only 2x square minus 3x, not added with 11. So now as you can see, I have the first quadratic expression right here and the second quadratic expression right here. Now the next steps are that we need to find further factors of this quadratic expression. So by taking a glance at the first expression, I conclude that there are no further factors for this expression, but for this second quadratic expression we can find further factors, and I'll show you how. So here the coefficient of x square is 2. So if we multiply 2 with negative 5, we will get the resultant of negative 10. So now we need to find the factors. So the factors will be negative 5 and positive 2. So we will place them into this quadratic expression. So then what I will do is I will write 2x square. It will be subtracted from 5x, then added with 2x subtracted from 5. So now I have 4 terms. Now I need to pick the common between them. So it will be only x, because 5 and 2 aren't related with each other. So I'll just write x bracket 2x subtracted from 5, and then I'll take the common value of 1, positive 1 here, and I can write 2x minus 5 as it is. Now the factors will be 2x minus 5 and x plus 1. So we found further factors of this second quadratic expression. So in the end, we will conclude by this answer that the factors are, and we will state all of the factors that we found. So the first factor that we found was for the quadratic expression a plus 11. So that was 2x square minus 3x plus 11. What will the second factor be? It was 2x minus 5 and it was x plus 1. So this is our final answer for question number 30. Okay everyone, so let's start with question number 14. I will write question number 14 right here. So we have expression which is y square added with 2y subtracted from 3. And then we have y square plus 2y being added with 11. And then we have 48. So this expression is quite similar to the previous question number 13. As you can see, we have y square plus 2y and y square plus 2y here again. So we can consider that as any variable, suppose a. So I will write let y square plus 2y be equal to a. Now it will be easier for me, so I'll just write a minus 3 and I will write a plus 11. So these are my factors and we do not need to forget positive 48. Okay, so now what we will do, we will multiply this whole term with this term. So that will be a bracket a minus 3 and then I will write 11 bracket a minus 3 and then we have plus 48, so I'll just write that at the end. Now what do I need to do next? So a multiply with a is a square minus 3a plus 11a plus minus is minus and 11 multiplied 3 is 33 and then I write 48 here at the end. Now what is our next step? Here we have negative 3a being added with 11a and then we have negative 33 being added with 48. So we need to simplify both of these terms. So let's write a square minus plus is minus, but the sign will be plus. And then we will have 8a. Okay, what is our next step? Then negative and positive is negative, but the sign will be positive because here the sign is with a greater number. And then 33 subtracted from 48 will be equal to 15. So look, now we have a quadratic expression again. So assuming the coefficient of a is 1 and here we have a numeral which is positive 15. So 1 multiply positive 15 is equal to 15. Now we need to find the factors of 15. One such factor is 3 multiply 5. So if you multiply 3 with 5, you will get 15. But if you add them up, it will be equal to 8. So we will use these factors for this quadratic equation. Now I will write a square. After that, I'll write, instead of 8a, I will write 3a plus 5a being added with 15. And then I'll take the common between these two terms. So a bracket a plus 3 and then I'll write 5 bracket a plus 3 because 15 divided by 5 is 3. Then I have a plus 3 as my first term and then I have a plus 5 as my second. Now what do we need to do next? So we need to place the value of a. So the value of a was equal to y square plus 2y plus 3. So this was the value of a. We need to place it right here. So it will be y square plus 2y plus 3. So this is the value for the first term, and for the second term, what will it be? It will be y square plus 2y plus 5. So here we have two quadratic expressions. Now can we simplify them? Okay, so if we try to simplify them, we find out that we cannot simplify them much further. So our final answer will be these two quadratic expressions, or you can simply write the factors are, and you will write the first factor. So first factor is y square plus 2y plus 3 and the second factor you need to write it just here, but because of the congested space I'll just write it below. You will write y square plus 2y plus 15. So this is our final answer. Now let's move on to question number 15. I'll write question number 15 right here. Now question number 15 states that y bracket y minus 1 is, then we have y minus 3, it's multiplied with y minus 3 and y minus 4. added with 2. Now, by just taking a glance at this equation or expression, you might wonder that we will multiply y with y, then that will be y square and then negative y, and then we will multiply these two terms, but that is incorrect. You won't follow those steps. So what will you do? You will multiply y minus 1 with y minus 3, and then you will use this y and multiply it on y minus 4. That's the correct steps. So I'll just write y minus 1 here, then I will write y minus 3 here, and then I will place 4, and after that I will write my minus 4, y minus 4 right here. Then it will be added with 2. So after writing that, now what do we need to do? So these two terms will be multiplied with each other. That results in y bracket y minus 1 minus 3 bracket y minus 1. So here I have multiplied these two terms. Then we will multiply both of these two. That will result, okay, I think I made a mistake. This is not 4 bracket y minus 4. It is y bracket y minus 4. So I'll just fix that real quick, and then I'll have y square minus 4y plus 2. So we need to place a bracket here, and because this is outside of the parenthesis. Okay, after doing that, I'll just write y square minus y. Instead of 1y, we just write y because we assume that the coefficient is 1. And then we subtract it from 3y, minus minus is plus 3. And then we will add a bracket on this expression right here. And then we have y square minus 4y plus 2. Okay, now we need to simplify this much more further. We have negative y being subtracted from negative 3y. So what will this produce? It will produce negative 4y, and then we have y square and then positive 3. So this is our first term, and this is our second term, which is y square minus 4y, and then 2 is placed outside. Now look, what common thing do we have right here? So we have y square minus 4y and we have y square minus 4y. So let us consider this as a. So I'll just write here that let y square minus 4y be equal to a. So I'll just remove the y square minus 4y, and I can easily write a plus 3 instead of this value, and I can write a, and then we have 2. Okay, so these two will be multiplied, which results in a square plus 3a plus 2. So now we have a simple quadratic expression with the coefficient of a square as 1 and the numeral as positive 2. So I'll write 1 multiply 2, that results in 2, and if I plus add them up, it results in 3. So these are the factors for my quadratic expression, so I'll just use them. A bracket a plus 1, and then I will write 2 bracket a plus 1, because anything divided by itself is always 1. So I'll have a plus 1 and a plus 2. So what do we need to do next? We'll write down the value of a again. So the value of a was y square minus 4y. So for this first term, it will be plus 1. And for the second term, it will be y square minus 4y plus 2. So here we have two quadratic expressions. So we need to simplify them. So can we simplify them? No, we cannot. There aren't any factors for these two quadratic expression. So this will be your answer, or you can just write the factors are, and then you will write the two quadratic expressions because they are the only factors. So y square minus 4y plus 1, and then you will write y square minus 4y plus 2. So this is your answer for question number 15. Now let's move on to question number 16. So question number 16, I'll write k plus 2, then we have k minus 3, we have k plus 5, and then we have k plus 10. So after writing that, at the end, what we have left is positive 375. Okay, so by taking a look at this expression, you will conclude that this will be multiplied with this and this will be multiplied with this, but that is wrong. And you know, if you multiply these two factors and then these two factors, okay, that is possible, but the solution will be quite difficult for you all. So I'll just not make it complicated and use the other method which was provided in your book. So we will multiply this k plus 2 with k plus 5 and k minus 3 with k plus 10. So let's arrange it first. So we will write k plus 2 and k plus 5 alongside each other, and then I will write k minus 3 with k plus 10. After that, I will add 375. Okay, what do I need to do next? I will multiply these two terms and these two terms. So k bracket k plus 2 and plus 5 bracket k plus 2, and I'll just place square brackets here because this is the first and this is the second. So I'll just write square bracket here. I'll write k bracket k minus 3, and we have positive 10 bracket k minus 3 again. So I'll just close this expression, and then we will have positive 375. I don't have that much space. I'll just write it here. Okay, so what do I need to do next? I need to simplify it. So I'll just write here k square plus 2k plus 5k plus 10. So I'll just use the square bracket again here, not the parenthesis. We will use it later on. And then I'll write here k square minus 3k plus 10k plus minus is minus 30. So I'll write it here, and then it will be added with 375. So I will write 375 here. Okay, after writing that, what do I need to do next? You will see that we have 2k and 5k. When we add them up, we will have 7k, and this will be our first quadratic expression. Now what will be our second quadratic expression? Okay, so here we have negative 3k plus 10k. So both of these will cancel, and then we will have negative 7k k square, and then we will have negative 7k. Okay, no, we will have positive 7k, and then I'll have positive 10k here. So I'll just remove the square bracket now, and I use the parenthesis. Okay, now we have two types of quadratic expression, and you do not need to forget the 375 at the end. Now we are going to solve these expressions, but here we have k square plus 7k plus 10, and here we have k square plus 7k plus 10. So what we will do, we will pick, okay, I think I made a mistake here. This shouldn't be 10k because we already have 7k here. So yep, I made a mistake. This will be 30, and it will be negative 30. So look, now I have k square plus 7k here and k square plus 7k. So let's assume this as a. So I will write let k square plus 7k be equal to a. Then we can write a plus 10 and a minus 30. After writing that, what will we do? They will also be added with 375. We do not need to forget that. Okay, so we have a plus 10 and we have a minus 30. So we can, okay. Yep, so we will multiply these terms first, and then we will check for their factors. So I'll just write a bracket a plus 10 and minus 30 bracket a plus 10. After writing this, what I will do is write positive 375 as separate there. Okay, so a square plus 10a will be subtracted from 30a, minus plus is minus, and then we have 300 and added with 375. Okay, so after this I just have a square both of these will be cancelled and they will produce 20a, and then 300 subtracted from 375 is 75. So there I have this quadratic expression. Okay, so I have this quadratic expression. Now the coefficient of a square is 1. We have the numerator as positive 75. So 1 multiply positive 75 is 75. But what are the factors of 17? If you remember, if you divide 75 with 15, you will get 5. So we can use the factors 15 multiply by 5. Okay, so we can use these two factors, but we will have negative 15 and negative 5. So let's just place them in this quadratic equation. So I'll write a square, then I will write negative 15a, then negative 5a being added with 75. After that, we will get the common, which is this, and minus plus will be minus 5 bracket a minus plus minus and 5. Wait a minute, 5 and 75, we will have 15. Yeah, 15. And then we will pick a minus 15 and we will here pick a minus 5. So these are our two factors. Now we need to replace the value of a. Now let's place the value of a. So what was a equal to? Let me, yeah, so a was equal to k square plus 7k, and now we will write k square plus 7k minus 15 for the first factor. So this is the first factor, and then k square plus 7k minus 5, this is the second factor. So here we have the first quadratic expression, here we have the second quadratic expression. Can we simplify them? No, we cannot. So the answer will be these factors, or you can simply write the factors are, and you will just write here k square plus 7k minus 15. After that, what you will do is write the second factor, which is k square plus 7k minus 5. So this is the answer of question number 16. Okay, so now let's move on to question number 18, because I reviewed question number 17 and it is exactly the same. So I want you guys to practice it by yourself. So let's write question number 18. So question number 18, here we have an expression. It is x plus 1. Then we have x plus 2. We have x minus 3. What do we have next? Then we have x minus 6, and then we have, yep, 21x square. So what do we need to do now? So here we have x plus 1. Instead of writing x plus 1, we can do it with 6 here, and then x plus 2 with x minus 3. So first we will arrange it into this format. So okay, so what will I do first? I will write x plus 1, it will be with x minus 6, and then I will write x plus 2 with x minus 3, and do not forget that you need to add 21x square at the end. Now let's multiply these terms. So how will we multiply these pairs of terms? You will write x bracket x plus 1 minus 6 bracket x plus 1. So this is the first multiplication term. So I'll just put a square bracket here because we need to differentiate it from the second. So I'll write a square bracket here too. So this will be x bracket x minus x plus 2, and then we will write minus 3 bracket x plus 2. Okay, so we have these multiplied. What do we need to do next? We need to close this square bracket, and we have 21x square here. Okay, so now what do we need to do next? We need to simplify it much further. So x with x is x square plus x minus 6x, and minus plus is minus, so 6. So this is our first expression, but it is not simplified. We need to simplify it much further. We will do it in the next steps. Then we have x square plus 2x. Then we have, what do we have? I wait a minute. So we have 3x minus plus is minus, 3 2s are 6, and then we will close this with a square bracket. So here I have this with a square bracket, and then negative 21x squared, do not forget that. Okay, so we have x squared, x minus 6x. What is x minus 6x? So it will be minus 5x minus 6x squared. So this is our first quadratic expression. And then in the second we have 2x minus 3x. So this will be minus x. So x squared minus x minus 6. So this is my second expression. And then at the end we have 21x squared. Okay. Now what do we need to do next? We have x squared minus 5x minus 6. We have x squared minus x minus 6. Okay, so we need to find the common value between these two. You might be you might be saying that we have x squared minus 5x minus 6, but there is x squared minus x minus 6, so there isn't any common value between them. But you're wrong on that. Look, we have x squared here subtracted from minus 6, and we have x squared here subtracted from minus 6, so we can choose that as a common value. But first we need to arrange it. So I can write x squared minus 6 minus 5x. After doing that, I will write x square minus 6 minus x as it is right here too, and minus 21x square. Okay, after writing that, we will choose x square minus 6 here and x square minus 6 as a common value. So I can write let x square minus 6 be equal to a. After writing that, I can write a minus 5x here, and then I will write a minus x here. So we have these both expressions right here. Now it is subtracted from 21x square. Yeah, it is subtracted from 21x square. Now what do we need to do next? We need to multiply these terms. So I'll write a bracket a minus 5x subtract from x bracket a minus 5x, and then subtract from 21x square. Okay, what will we do next? We will write a square minus 5ax subtracted from ax minus plus as minus as plus, so 5x square. Then I'll write 21x square here. Okay, now I write a square and then 5ax with 5ax, so that will be minus 6ax, and then we have 5x square subtracted from 21x square. I'm aware that it is 16x square. So here we have the quadratic expression, which is 1a square minus 6ax minus 16x square. So we need to solve this much further. It isn't completed right now. So what do we need to do next? We need to make the factors. Yeah, so here we have the coefficient of a square as 1, and here we have 16. So 1 multiplied negative 16 is 16. The factors, what are the factors? It will be a square minus 8ax plus 2ax, and what will be next? I think it's 16x square. After that, we will take both of these terms. We will take the common value 8a minus 8x, and then we will choose between these two. It will be 2x, so I'll just pick 2x bracket. A minus, I'll just pick 8x. Yeah. Oh, and then we have a minus 8x here, and then we will choose a with plus 2x. So a plus 2x. So these are our factors, but it isn't still completed yet. We need to place the value of a. So a was equal to x square minus 6 minus 8x. Now let's place this value. Okay, so it wasn't minus 8x, sorry, it was x square minus 6. So I will write x square minus 6 minus 8x. So this is the first quadratic expression, and instead of a plus 2x I will write x square minus 6 plus 2x as the second quadratic expression. Now can we further multiply these two? No, we cannot, but we need to swap them. If you remembered, we swapped the values, but if you look at this quadratic expression, the quadratic expression is always in first the variable, then the second is the variable, and the last is c, which is basically the numeral. But here if you look, we have the variable, let's suppose x, then we have the c, and then we have the variable. This is wrong, so we need to swap their positions. So for the first equation, we will write x square minus 8x minus 6. This will be the corrected one. And then for this second, we will write x square plus 2x minus 6 as 2. So this is our final answer for question number 18. We read out the question. It is question number 21. And let's read the question. So it says that we have an expression, and that expression is a power 6 added with 729. It's saying that it can be written in two ways. The first way is as a sum of two squares, and the second way is as a sum of two cubes. So basically it's saying which one will be used for factoring at and why. So they are saying to us that which one will be used for factoring it and why, and we will also factorize the given expression which is above. So let's attempt the first part, then the second, and I'll show you which one will be factorized and why. So here we have a power 6 plus 729, and then we have we need to write the sum of two squares for it. So I can write here a power 3 whole power 2. It is the same as a power 6, just in an expanded form. Now what is the square root of 729? It is 27. So I can write 27 whole square. It is the same as 729. So what is this? This is the sum of two squares. But now what if I want to convert it to two cubes? Then what will happen is that instead of a power 3 whole power 2, you will write a power 2 whole power 3, and it will be added with 9. Yes, so what you will do, you will write 9 whole cube. So this is our answer for part B. Now in part C, they are asking that which one will be used for factoring it and why, and which one should be factorized. So look, the first formula, it was a square plus b square. So there isn't any general formula for a square plus b square. However, there is one for a square minus b square. So we cannot factorize the first one completely. We can just write it as the sum of two squares. But in the second part, we have a cube plus b cube. So obviously this formula exists. It is a general formula which we used throughout this exercise. So yep, we can factorize the sum of two cubes completely. So let's factorize it. Okay. So firstly, the value of a is a square and the value of b is 9. So a cube plus b cube, what does it state? It states that a plus b, and then it states that a square is being added with b square subtracted from a and b. Now what will I do? I will place the value of a and then b. A was a square, so I will write a square plus 9, and then I will write a power 4 because a square will be a power 4, then 9 9s are 81, and just I will write 9a square here. So this will be our final answer.